we will be making citrazinic acid. The yields are not so good, but the raw materials are very cheap and easy to come by. Start off with 75 grams of citric acid. Our citric acid claimed to be pure acid but was in fact the monohydrate, so try to find out what it is you have. Next, weigh out 60 grams of urea. This is OTC in some types of instant cold packs, although be careful because other salts such as ammonium chloride are also sometimes used in these. Mix the urea and citric acid together and crush up to a very fine powder like this. Then place the mixture in a suitably sized beaker on a hot plate with the thermometer in the solid but not touching the bottom of the beaker. We heated this mixture strongly at 70 degrees C. The mixture started to liquefy, and then a yellow color became stronger and stronger. Ammonia gas was also emitted as the mixture bubbled. This occurred at above 130 degrees C. The temperature then slowly increases, and the mixture turns a caramel and darker color. Here we are about 50 minutes into heating and at a temperature of 150 degrees. Little ammonia is now being produced, and the liquid is a thick syrup like treacle. We stopped the heat at this point. On cooling, the syrup forms a solid glassy mass in the bottom of the beaker. Add 150 ml of boiling water to the beaker and stir the water. With a little time, everything appears to dissolve, forming a dark brown with a yellow-colored tint on the glass. The pH of the solution at this point was tested, and was around 6, very slightly acid. We added a small amount of sodium hydroxide solution to change the pH to 9 in order to make sure the product was all turned into soluble salts. Then we filtered the solution using a sinter and vacuum. This was very slow due to a very fine black terry solid present in the liquid, and took 1.5 hours to complete. Here's the dark solution we obtained. We then added concentrated hydrochloric acid to this in order to precipitate the product as the free acid. An orange-yellow precipitate is formed and seemed to be complete after around 20 ml of acid was added. We filtered this precipitate and dried it as best we could on the filter, then washed with a small amount of ice-cold water. We took the resulting solid and dried it in a desiccator over anhydrous calcium chloride for 1 week. We're not sure if this is a necessary step though. We wanted to purify this a bit further, so we washed the resulting solid with 30 ml of methanol, and then chilled the mixture to reduce solubility of the product. On filtering, this seemed to remove a lot of the darker brown color in the filtrate. We washed with another 10 ml of cold methanol, and then washed with 20 ml of dichloromethane. Finally, we got the product dry by leaving it on the pump and breaking up any lumps. So here's what we ended up with: an attractive golden yellow fine powder. Some references say that this is the free acid, and others claim it is the corresponding amide. We obtained 7.73 grams, and if it's the acid, that corresponds to a 14% yield from starting citric acid. We attempted to recrystallize this further, but couldn't find a solvent or mixture with enough solubility variation from boiling point down to room temperature, so we'll use this as is for further experiments.